All right, guys, let's go over this worksheet, see how we did. So we are expanding our understanding of vectors. We are using vector arrows here to aid in our investigation. So we have this bank full of vectors, and they're all labeled. And they're on this grid so that you can tell what their magnitude is. And in addition to that, they're labeled for you as well. But also, again, this is going to be the part that's probably the trickiest for you, is that there is a direction. Okay, there is a direction. Number one, which vectors have the same magnitude? So what I'm looking for is arrows that all have the same length. Okay. Now, this question is asking about magnitude, so I get to ignore direction on this one. All right, so I'm going to look for arrows, for example, that are all 3 meters. 3 meters, okay? So for my 3 meter bad boys, I would have A, C, I would have E. What else would I have? Cool beans. And then, what's one I haven't got yet? I got some 4 meter ones. All right, so that would be D, G, and is that it? Okay. And then I need to represent my 2 meters. 2 meters. And so that would be E. Cool beans. Right? Now again, all these arrows are going all different directions, but I don't care for this particular question because I'm only being asked about the magnitude. Now number 2, which vectors have the same direction? Direction. Let's go. Let's start with the one that's going up. It's a beautiful U. Thank you. We would have A is going up, D is going up, H is going up, and I think that's it. So, which ones are moving to the right? B and C are right next to each other, so that makes it easy. And then G. That's it for ones going to the right. And then both moving at 30 degrees from the horizontal is I and J. Straightforward, right? Which arrows, if any, represent the same vector, right? So it's absolutely possible that none of these arrows represent the same vector. But if there are, which ones? Let's see. I'm going to go A and H, right? You can see that they're both in the 3 meter camp and they're both in the up camp. So they're both 3 meters up. So A, H. All right, so now we're going to build our own vector diagrams here. All right, in the space provided, so right here, construct and label a diagram that shows the vector sum, right? See that? Vector sum 2a plus b. Now, how's this going to work? We all know that a is up. Well, what's 2a? That'd be 6 up, right? So I am going to draw a vector arrow going up, and it's going to cover 6 of these grid lines. Now, just because I have some experience, I'm not going to draw A right now because I don't know which direction B is going to go. Okay? So I know A is going to go up 6. B is going to be going to the right 2. So, because I want to have enough room, right, to stay on the grid, I'll start my diagram over here. So I'll go 1 line, 2 lines, 3 lines, 4 lines, 5 lines, and 6 lines. So there's my 2a, and then I need to add to it boom. Fair enough? Construct and label a second diagram that shows b plus 2a. Well, don't these end up being the same things? There you go. They end up in the same place. That doesn't mean they're the same vector diagram. Right? So B, I'll go over here. I'll start down here. There's B. And there's the 2A. Yeah? At number 5. In the space provided, construct and label a diagram that shows the vector difference. Okay, so we're doing something different here. Difference. A minus half B. A minus half B. All right, so A, start here, go up 3. There's my A. But I'm subtracting now, so I'm changing the direction of B as well as having its magnitude. So B was moving to the right before, but because it's a difference, I'm going the other direction. B also has a magnitude of 2, but since it's half of B, I'm going to move 1. Construct and label a second diagram that shows half of B minus A. Again, half of B minus A. Oh, sorry. You're right. My bad. Pop, 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 pop. That's not a minus. My bad. So, good call. I screwed that up. Yep. Positive B, but it's half of B. And then a negative A. Now, the big takeaway for both 4 and 5 is what you guys already mentioned, is that you end up in the same place. There's a special word for that we're going to start using, and it's resultant, right? The resultant is the same for both of them. Resultant is a vector word that means the same thing as hypotenuse, right? It's the hypotenuse. You go here. If you start here, you go there. Start here, you go there. Notice that those resulting, maybe even a displacement, right? The resulting displacements are the same, even though you took a different path. It's totally fine. The displacement's the same. Start here, go there. Now we're starting here, going there. Here, the magnitude of the resultant is the same, but it's in the opposite direction. Why is it in the opposite direction? Yep. Change in directions. That can get a little bit tricky because I could say like this. I could rewrite it, and it would look like this. So that I don't think I'd quite use that particular rule. It's more the fact that because of this negative sign, I have to change the direction of something. Up here in number 4, nothing ever had to change its sign, direction because of sign, and so they both ended up in the same direction. Here we're changing the direction of B, and then here we're changing the direction of A, right? And so we do actually end up in a different place.